We are often told that weight management is simple math, calories in, calories out. But biology doesn't work like a basic calculator. The exact same meal eaten by two different people can be burned efficiently for fuel or aggressively hoarded as fat. This schematic shows how the human body actually operates as an intelligent energy management grid. You have the incoming energy supply, which is the food you eat. You have the citywide distribution network, which is your circulation. And sitting right in the middle are the grid regulators, your gut microbiome. These microbes dictate exactly where your incoming energy goes. At baseline, a healthy grid thrives on alpha diversity. That is a measure of how many different microbial species live in your gut and how evenly they are distributed. High diversity means you have a flexible team of specialists ready to break down a wide variety of nutrients without overloading the system. Watch what happens when complex dietary fibers enter the hub. Humans cannot digest these fibers alone, so specific beneficial microbes step in to ferment them. They convert that raw material into short-chain fatty acids, or SCFAs, beneficial molecules that provide up to 10% of our daily energy. SCFAs are also metabolic messengers. As they move through the distribution network, they activate intestinal receptors, triggering the release of GLP-1 and PYY. These two hormones travel straight to the brain to reduce hunger and keep blood sugar stable. When these microscopic regulators are present and active, calorie intake stays balanced. But if this bacterial workforce is depleted or replaced by the wrong species, the entire communication network goes dark. Long-term weight management is built on the structural integrity of this unseen processing infrastructure. These microscopic regulators determine whether energy is utilized for movement or locked away in storage. When microbial diversity collapses, aggressive configurations like the BAC2 enterotype can take over. These obesogenic microbes act as over-retention systems. They harvest calories relentlessly from your food, but they fail to produce the short-chain fatty acids the gut needs to maintain itself. This animated diagram shows a cross-section of the intestinal lining. Without enough SCFAs to nourish these cells, the physical barrier separating the gut microbes from the bloodstream begins to thin. Cellular junctions loosen, and microscopic gaps open up. This structural failure leads to metabolic endotoxemia. Bacterial toxins called lipopolysaccharides, or LPS, slip through those weakened gaps and pour directly into the circulatory system. Once inside the bloodstream, these LPS molecules trigger an immediate alarm. They activate TLR4 receptors on human cells, initiating a state of chronic, low-grade inflammation that spreads throughout the entire body. Losing microbial diversity compromises the body's physical containment system. Digestion turns from a highly regulated energy extraction process into a continuous, toxic inflammatory leak. Systemic inflammation acts exactly like physical damage spreading through electrical power lines. It disrupts the grid's communication pathways, particularly the signals that tell cells how to handle incoming fuel. Look at the energy units moving through circulation in this diagram. Inflammation directly causes insulin resistance, meaning insulin can no longer successfully instruct active muscle tissues to absorb circulating glucose. The energy arrives, but the doors are locked. The system faces an emergency surplus. Because the energy cannot enter the muscle nodes, the body reroutes the excess fuel into adipose tissue. The fat storage reservoirs expand simply to clear the blocked supply from circulation. Certain obesogenic bacteria make the problem worse by producing metabolites like imidazole propionate and elevating circulating branched-chain amino acids. These chemicals directly interfere with insulin signaling in the liver, effectively locking the body into a state of permanent energy retention. The body hoards fat because inflammatory damage blocks energy from being utilized anywhere else in the system. We can repair this communication breakdown by introducing biological balancing controllers, often referred to as skinny bacteria. These specialized microbes actively repair the energy grid's hardware and restore accurate signaling. A prominent example is Akkermansia mucinifila. It lives directly inside the intestinal mucus layer, stimulating cells to build a thicker, stronger barrier. As it fortifies the walls, it secretes a signaling protein called P9, which reactivates those GLP-1 satiety signals and stimulates calorie expenditure. Then there is Christensenella minuta. It acts as a central coordinator for the gut ecosystem. It shares nutrients with other microbes to boost anti-inflammatory SCFA output, and it suppresses the bacterial production of those insulin-blocking amino acids. These specific microbial strains function as internal system administrators. They reverse metabolic damage by patching the physical leaks in the gut and rebooting the entire energy distribution network. Clinical trials indicate that a combination of intermittent fasting and protein pacing, or IFP, selectively suppresses obesogenic microbes while strengthening metabolic regulators. This strategy uses nutrient timing and quality to install a more resilient and efficient energy management grid. During the fasting phase, halting incoming energy forces the body to mobilize stored fuel. Interleukin-4 and interleukin-6 instruct adipose tissue to release stored fatty acids. Then, protein pacing distributes high-quality amino acids, starving obesogenic microbes while specifically multiplying Akkermansia and Christensenella. By controlling both the timing and the biological quality of the nutrients, you restructure the microbial ecosystem. Long-term studies show that these specific dietary shifts allow individuals to maintain high populations of beneficial bacteria well after their initial weight loss. Sustainable weight management is the active maintenance of a biological power grid. By strategically feeding and repairing our microscopic regulators, we restore the body's natural ability to balance its own energy.